Hi everyone, I'm David Wismer, a recent graduate of the Metis Data Science Bootcamp. And what I'd like to do today is walk through Hi everyone, I'm David Wismer, a recent graduate of the Metis Data Science Bootcamp. And during that bootcamp, I completed a project that used unsupervised learning techniques and natural language processing in order to show topic modeling, prevalence and sentiment across time, as well as some sentiment clustering information, all related to Bitcoin. And so what I wanted to do today was walk through some of the code behind this project and also show a demo of the dashboards that I've created. So let's go ahead and start with the demos. Here you can see a live demo of the app that is currently shared on Streamlit. It's called Tokensense, and I can share the link in the description of this video. And what you'll see here is we've got a drop down with several different tools available, starting first on this daily sentiment dashboard. So what we see here is some kind of general information about the Bitcoin price, looking at closing price, the change in price over the prior however many periods, and then also showing some sentiment information. So this is looking at the polarity and subjectivity of both news articles and Reddit comments for these days. So what we're seeing here is on this particular selected date of 6/15/2021, it looks like our news polarity is somewhere in the middle. Polarity is how positive or negative text is. This is as determined by TextBlob, a really useful library in Python. And then subjectivity is how opinionated the text is. So in this case, it looks like the opinionatedness of articles is lower than typical. Reddit comments collectively are slightly positive. Opinionatedness kind of in the middle as well. Really nothing particularly stand out in these box plots. As we scroll down, we'll also see some activity information. So we can see that this looks like a more active day. Trading volume is higher than typical. Active addresses in terms of blockchain usage, more than usual as well. Google Trends activity is higher relative to the full distribution, as is Reddit activity, or the number of comments. So as we continue to scroll down, we'll also see some information from glassnode.com. These are on-chain metrics. Net unrealized profit and loss is a measure of kind of how many people are in the money. It's kind of a really useful measure of sentiment in the Bitcoin community. When we reach these green levels, generally that is associated with belief and denial. And it's not showing in this particular chart because we haven't reached it, but there's also a level higher than that that's blue, when we're essentially in a euphoric state. And it's a good time to consider selling your Bitcoin. We also have net transfer volume, which is a measure of how much Bitcoin is moving onto or off of exchanges. When Bitcoin is moving off of exchanges, generally it's an indication that people are trying to hold because they're moving their money from exchanges to cold storage where they can't then sell it. If they're bringing their money onto the exchanges, it's because they're probably intending to sell that Bitcoin. And then down here, we just show some clustering information. This isn't really the best place to look at it. I'll show that in a bit, but we've essentially clustered historical dates by all of these different activity and sentiment metrics in order to understand what kind of day is today. So let's take a look at some of these others as well. So this one is Reddit sentiment. I won't spend too much time here because it's not really the most useful of the dashboards. This is kind of showing polarity and subjectivity across time, but there's not a whole lot to be drawn from it because it kind of all sticks in sort of a similar area, generally a little bit positive. It trends positive. It'll be interesting to see, when it falls outside of these box plot distributions. That's when you might want to pay attention to something like Reddit sentiment. Activity versus price, I won't spend time on. Sentiment cluster analysis. This is an interesting dashboard. So this is kind of showing our different clusters for all of our historical dates using a mixture of sentiment information, activity information, and also so what we see here is first some price action information as well. So let's filter by a different methodology. Right now we're looking at Gaussian mixture, and that's just one clustering methodology that seems to have kind of more stable clusters. If we flip over to k-means clustering with a k of 6, it says they're paused, but it looks like it updated. What we see here is some different color coding, obviously. Let's focus in on just 2 of these clusters. So we'll focus in on the blue and the purple. Oops, I need to select both at the same time. Okay, so now we've got blue and purple selected. And so what this shows is that the purple cluster tends to come when price is lower. Right here we're looking at the price versus the all-time high. So purple tends to come when prices are lower versus the prior all-time high, whereas blue tends to come when we've reached a new all-time high. That's also reflected in these box plot distributions by cluster. We see that the blue cluster is much higher or closer to prior all-time prices, whereas purple is when we are kind of in a valley after a crash. We also see similar things in net unrealized profit and loss, which is, as I mentioned, another kind of sentiment metric that is popularly tracked. Next, we'll look at activity. And again, we see that the blue cluster is associated with higher activity. So here we see when we're near all-time high prices and we've got lots of active addresses, that's when this blue cluster tends to appear. So this means that there's a lot of people trading Bitcoin, whereas in the purple cluster, there isn't a lot of trading going on. This is also true for Google activity. So there's a lot more Googling happening in the blue cluster versus the purple cluster, which is much lower. The same is true for Reddit activity. And now we get down into the sentiment area. And for Reddit, you can see we don't really have too much delineation between the different clusters for our Reddit polarity or subjectivity, although we do have a much larger distribution for the purple. So people tend to get more negative sometimes in these purple cluster days, which makes sense given the other correlations with lower prices and lower activity. And then if we look at news polarity and subjectivity, this is news articles as pulled from Bitcoin news article websites. What we see is that generally the purple clusters are associated with lower polarity and slightly lower subjectivity or opinionatedness of the articles as well. So now let's keep moving and take a look at some topic modeling visualizations. First, we'll look at topic modeling across time. So what this dashboard shows first is topic prevalence. So as we look down this list, we'll see a variety of different topics. Let's focus in on maybe just one of these topics, for instance, institutional investing. In fact, let's wait until we get to the deep dive to do that, the deep dive dashboard. But what you can see is, for instance, famous investors became very popular in Q4 of 2017. As we scroll through over here, we see this visualized as well. You can see here the bull run became a very popular topic during this time in 2020, and then kind of starting to peter off as the crash began. And yeah, we'll save some more of this for when we get to the deep dive dashboard. We've also got down here at the bottom some topic polarity trending across time, so we can see, across these quarters what our polarity was for the different topics. But again, I think a good place to look at this is actually the topic deep dive dashboard. So here you can select either a single topic or a combination of topics, because we do have certain topics that are closely related. For instance, you might want to combine things like global adoption and government regulation, or you might want to combine crime, with hacks, for instance. In this case, we're just going to focus in on the topic of institutional investing. And so what we see here, first is polarity versus subjectivity across time. These bubbles are different articles from different websites, and you can mouse over them to see the information about those articles. Here we see the topic polarity and subjectivity across time, trending down slightly in Q1 and Q2 of 2021. Down here at the bottom, we see topic prevalence, and we see that it peaked around 11% in Q1 of 2021. And then what we're seeing here are the top articles that describe or relate to this particular topic of institutional investing. And you're going to see big institutional names in here, things like MicroStrategy or Grayscale. You probably see things like Tesla in here as well, I imagine, because there was big news about Tesla buying Bitcoin as well. So you can also filter these articles by their topic percentage, meaning like this has an 83.6% topic share related to institutional investing. So this is this single article with the most relevance for institutional investing in our entire database. Shows the polarity, subjectivity, and word count as well. Okay, so that's the topic deep dive dashboard. We can also look at polarity versus subjectivity, and what you see on here is subjectivity across the bottom, again, opinionatedness, and polarity on the y-axis, or how positive or negative articles are. In the bottom left, you're going to see things like crime, government regulation, lawsuits, more negative sounding topics. And in the upper right, you'll see things like blockchain innovation, famous investors, education, community, things that are more positive in nature. And then finally, I'd like to show the LDA visualization. This is latent Dirichlet allocation visualization. So what this shows is, and again, we can focus in on our topic, institutional investing. If we were to click on our topic, we would see the top terms that are relevant to our topic, things like investment, institutional, obviously, company, asset, etc. If we adjust our lambda, we'll even see some of those big entities come through: Grayscale, MicroStrategy, JP Morgan, Fidelity, etc. So that more or less covers the Tokensense application and the set of dashboards on this web app. So let's go ahead and get into some of the code behind this whole project. Here I am on my GitHub, and what you'll see is it's nicely organized into several different Jupyter notebooks. Let's look at a couple of these. The first is web scraping. I'll go ahead and pop that open another. We're also going to want to look at maybe PCA and clustering, probably topic modeling as well. Okay, so we'll start with web scraping. If you're new to web scraping, this could be a good resource for you to work out some certain problems. One thing that I needed to do was scroll to the bottom of a page. When these are not paginated websites, sometimes you need to have a function to scroll to the bottom of the page in order to load more articles. So that was one trick that I needed to figure out, and found a nice little function online to do that. In this code, I'm using things like Selenium to do web driving, and then also Beautiful Soup to do some parsing. So this first one is for Bitcoin Magazine. The next one is Crypto Slate. And you can see for this one, we didn't really have to do any scrolling. We just kind of needed to collect links. And Bitcoin News, and then also Cointelegraph. These are the 4 websites that I scraped. You can see some of them do require scrolling and some do not. So I scraped all of the articles. Oops, I need to fix my video. Let's go ahead and do that really quick. Okay, I'm back. So, as I was saying, oh, just one moment. Okay. Where was I? I scraped the news articles. After scraping news articles, I needed to do some EDA, I did some EDA on those, which I won't necessarily go through, but I did cut out certain articles that either weren't relevant enough to my topic of Bitcoin. Perhaps they didn't have Bitcoin in the topic or in the article name, and they didn't include enough Bitcoin in the word count. So I excluded certain things. I also excluded data before 2017 for my topic modeling because the data was too sparse, but you can find information about that in the EDA for the articles here. I also have some EDA for Google and Reddit information that's interesting to look through. But next, let's look at PCA and clustering, not for article topics because that didn't actually work out particularly well. What we actually want to look at is the PCA and clustering for sentiment analysis. Doesn't want to load though. Because that's the case, I will instead open this up here. PCA and clustering. There we go. So I'll open this with my Jupyter Notebook viewer. So what we see here is the PCA and clustering notebook. We're going to do a variety of different methods. So I brought in Gaussian mixture, k-means, dbScan, as well as some others I think I imported later on. And a variety of other tools that were kind of just used throughout. First, I needed to import all of my data. I have a separate module for doing database interactions to bring information regarding Reddit posts and comments, Google Trends, Glassnode information, and some trading volume information into my Python environment. I needed to do some feature engineering, calculating all-time versus all-time high for certain columns. So looking at the trading volume, for instance, versus the prior all-time high, and for some other things as well. For calculating polarity and subjectivity, I did not end up using Vader. I ended up instead using TextBlob. Vader might be part of TextBlob, I'm not sure, but TextBlob is technically what I used, the library that I used. TextBlob calculates polarity and subjectivity of text, polarity being the positive or negative nature, subjectivity being the opinionatedness of text. I also needed to group everything. So I needed to group by date because if I have a bunch of news articles, I can't do too much with it looking at the polarity across time. I need to associate these articles with a date and group them in order to say, well, okay, what's the collective sentiment of this given date, given the news articles that I have access to. Did the same thing for comments as well from Reddit. And this is just some EDA, calculated some news article polarity and subjectivity as well. Same thing I did for Reddit. Obviously needed to combine everything into a single data frame in order to do clustering. Gonna want to handle any, not a number, any NA values within your data set as well. And then we get into the clustering. So in order to do PCA, you want to make sure you scale your data. So I was standard scaling my data before doing any clustering here. And then we want to determine the optimal number of PCA components. So PCA, or principal component analysis, is the act of reducing your components to make everything faster, take less time. If you have, thousands of features, this can be more necessary than really my particular problem, but I did want to do it anyway. I only had 11 initial components, which I was able to ultimately reduce down to 8, still explaining 95% of the variance within my data set. So that was good, but you can imagine if you had hundreds of features and you could reduce down to, say, 20 components or something, that would really save you a lot of space, time, and performance. So ultimately I picked the number of PCA, and then did k-means clustering, choosing the number of clusters by looking at silhouette scores and the elbow method. So the elbow method is looking at where's the elbow within our cluster here. As we increase the number of clusters, looking at the sum of the square distances, you probably want to choose something kind of in this range. And ultimately I brought forward a few different clustering methodologies into my Tableau public dashboards, including a k-means cluster with 6 clusters, and also k-means clustering with 9 clusters. So as we look at some of the visualizations, it's hard to really tell much from just a 2 principal component plot here, but we can see a little better with a 3 principal component plot. And also within my PowerPoint presentation, which I've linked in the description below, I've created some GIFs that rotate these 3D plots to be able to see how these clusters are separated, which is a really nice thing to be able to do. I did the same thing for all of my clustering methodologies, looking at dbScan as well. One thing to notice with dbScan is that it finds density, and even with significant hyperparameter tuning, I really couldn't get it to make sense. Some of the clusters were just way too small. It didn't have enough points within them, so it wasn't a very useful exercise. So the density-based ones really were not particularly effective. Here for Gaussian mixture, the selection of clusters, you can use BIC and AIC. You can look these things up in order to help. You're kind of looking for where is this local minimum, or elbows are also a method as well. So yeah, this is where I'm doing all of the visualization for Gaussian mixture. I also looked into hierarchical agglomerative clustering. Was not particularly useful, but I believe I did include it here in my app. Let's actually look at the ones that I did include. If we look at our sentiment cluster analysis dashboard here, the ones that I included were Gaussian mixture, hierarchical agglomerative clustering, and the k-means methods. And as you select them, you'll see kind of how the clustering changes in the color coding. The color coding, they're not going to be the same across the different ones, in terms of the blue being kind of the high flying as it was in k-means. That's not necessarily going to be the case. Okay, back to the code review. This is really just more visualization. I also looked at one versus rest for my clusters. This is more just kind of EDA around the clusters to see, okay, for these clusters, where are they differing? So this is like cluster 0 versus the rest of the clusters. It looks like generally for net unrealized profit and loss, one particular thing, it's got very high net unrealized profit and loss, high closing price versus all-time high. These are things that we saw as we reviewed the Tableau dashboards. And that's about all I want to cover within this particular workbook. I don't think there's much more to see here. I did do some Tableau data preparation. A lot of the actual analysis can be done in Tableau in those dashboards that I ultimately created, not so much in the Python environment. So let's see, we've been through the web scraping. We just went through the PCA and clustering. And then let's also look at topic modeling. I don't want to go too in depth here either because there's a really great article, and it's right here, this resource right here, this Machine Learning Plus specific to GenSim and Python topic modeling. It's very useful for me. It helped me to kind of lay out my project and run through natural language processing in a way that made sense. So I won't go through this in too much detail. I'll kind of just hit the high points. First, we needed to reshape our data for LDA. So this is doing things like converting our articles into words. We got to get rid of stop words. We got to create bigrams and trigrams. These are two combinations of 2 words or 3 words. Lemmatization as well. So we only wanted to keep nouns, adjectives, verbs, and adverbs. I was doing things like replacing kind of extraneous characters, and yeah. You also need to create a dictionary and term document frequency matrix for use in the GenSim modeling, the LDA model. I also wanted to filter out the most frequent and infrequent words. For instance, do I really need Bitcoin to be in my dictionary, my corpus? If it's appearing in every single article, I probably don't. And the same thing with very infrequent words. If they're never appearing, it's not really useful either. And then we get to LDA parameter tuning. So this is a custom function that I built. It's kind of the meat of everything. What it's doing is looking at all of these different parameters within the LDA model. You pass in the lists of these parameters that you'd like to test. For instance, I want to look at these number of topics and these values of decay, etc., etc. And what it'll spit out is a data frame sorted by coherence. So we can see, okay, so what were the parameter combinations that gave us the best coherence score as determined by the LDA model within GenSim. Here's an example of that. So for instance, here we've got a coherence score here. These are our different parameter values that reach this. So then from here, I would then do kind of another run, kind of tinkering in and around these different parameter values to see if I can get even better. So ultimately, I'm doing lots of this. I increase my coherence score by a little bit from kind of like 51 to 50, nearly 53, and then do model selection. So my optimal model is here. Here you can see my optimal model's parameters. And from there, what I wanted to do is take a look at these topics. So first, I'm looking at right here, I'm printing out, using this code shown right here, the top 10 keywords for each of my 25 topics. So this can go a long way in helping you to determine what are these topics. For instance, here you're seeing investor, investment, institutional, firm. Remember we looked before at institutional investing. I think that's probably this topic here. But what I found to be an even better way to look at that was looking at the actual articles, like the top articles for each topic, but we'll get there soon. Then I wanted to store the topic breakdowns by article. So for each and every single article, you want to know, okay, what is the topic breakdown? So for article 0 here, we've got our 25 topics across the columns and the topic share for each one of these, kind of looking like it's probably going to be well, definitely, because 52% of it is related to topic 19, which again was that probably institutional investing topic from above. So here what we're doing is we're trying to figure out what is the dominant topic for each of our different articles. But not just that, it's also useful to know having these topic distributions will help us determine topic breakdown by day as well, not just by article. So here's a little visualization. it doesn't actually show it here, but this PYLDA viz, this is what we showed on the Streamlit app in the LDA visualization tab. So if you want to see the code behind this, first of all, it's very easy to look up, just LDA visualization. But if you want to see the code behind it, this is where you'll find that. I also applied topic labels here for use in Tableau as well. So after I applied those topics within Tableau, then I was able to do interesting things within the Streamlit app to look at prevalence across time, etc. But where did I actually calculate that? It must have been in here. Store topic breakdowns by article. No, there must have been more. This can't be the end, because at some point I must have calculated daily sentiment by topic. PCA and clustering. I think it must have taken place in the PCA and clustering dashboard as well. Let's take a look. I'm just curious to know exactly where the calculation happened for. No, it's not in here. Because this is PCA and clustering for, oh right, that makes sense. So where this may have actually taken place is the PCA and clustering with article topics. So even though the PCA and clustering didn't ultimately make a whole lot of sense, but within here, I do calculate the daily polarity and subjectivity as well. So we've got our clustering and stuff in here, not particularly useful. But as we get down to the bottom, you'll see we've got our dominant topic by article sentiment analysis. And so here what we're seeing is that because we've assigned, where did I assign it though? I don't know exactly where it is in the code, but ultimately what's happening is I'm assigning a dominant topic to every single article, and then on a daily basis we have data preparation. Okay. Here's kind of where it's happening in this Tableau data preparation area down here. So the first thing you'll see here is I'm labeling my topics. So the way I labeled my topics was for any given topic, I wanted to look at a subset of the articles. So here we're looking at, for instance, topic 22. So I want to look at the dominant share of topic 22 in my database, sorted for highest dominant share. So if I look at these this is going to be the topics that are most related to this particular topic of topic 22, and you're seeing things like Fed printing, USD versus gold, Goldman Sachs gold, hedge fund CEO. It looks like a lot of this is related to gold, so I probably labeled this as, Bitcoin as a commodity. I think that was the name for this particular topic. And, oh yeah, here we go, topic 22, Bitcoin as a commodity. So I came up with my labels for all of these after doing that review, And then I assigned them to the data frame, and I also have my topic distributions here for every single topic in my database, which is around 19,000 articles, I should say, not topics, in the database. And then from there, we do grouping by date. So we want to group by date and topic label to say, okay, what is our polarity, our subjectivity, and also our prevalence by date. And then all of this is put into an Excel file that can be uploaded to Tableau, where we do all of our additional analysis. Okay, so the last thing I want to go through on my GitHub here is the Streamlit app. So let's pop this open. It's really simple, really nice. Streamlit is a great tool for building simple websites, and using Tableau Public and just embedding those into your Streamlit tabs is kind of a cheat code. It's almost too easy to build these applications. So here we import Streamlit. I needed Plotly for certain things. This is the LDA visualization. So here we've got our formatting, nothing special here. A couple of functions used for putting in my Tokensense title. My title up here with a picture. This is for creating little text blurbs as well. For instance, what you see here beneath this title is like a little text blurb. And this is for showing Plotly information. All right, and then we get into the page construction. So I create a sidebar, this select box. All you have to do is just make a variable and set it equal to this sidebar, and you can set your options. And that's what this is right here. Makes a sidebar, and it makes these options. And then in order to actually use these options, and by the way, this is continuing to do things within the sidebar, just kind of writing some information. And then here you just write little if statements. So if that variable that we set is equal to daily sentiment dashboard, well then construct the page essentially. So what does that page look like? If we do select that, so this is selecting that page's variable and making it equal to daily sentiment dashboard, well, what that's going to do is now construct this little web page. And as we can see, it's got a title, it's got a text blurb, and it's got this HTML code. And I bet you can guess what this HTML code is. It is the code from my Tableau Public dashboard. So you can look up how to do this kind of thing, but essentially then you just write this little code here, tell it how wide and tall you want it to be, and then that will bring in the embedded Tableau dashboard. And that is essentially what you do for everything else. So you can see here I've got an if statement for if pages is equal to all of these other potential web pages within the drop-down menu, the last one being the LDA visualization, and that's all there is to it. So really recommend Streamlit. If you have any questions about the code that I've written here, or are just interested to know more about this project, feel free to reach out or make a comment in the YouTube comments below. I'll also post links to a Medium blog post as well as a PowerPoint presentation that I gave for a succinct presentation of this project. Thanks for your time. I appreciate you listening.